We've made a lot of videos about Betelgeuse. It's one of the most familiar stars in the sky, the bright red shoulder star of the constellation Orion, the Hunter. And we've talked about its incredible variability and even its dimming in 2019 and 2020, which was dramatic and unexpected and got everyone excited for a supernova. And then it didn't explode, which, okay, fine, it'll do it someday. But while we're waiting, we're still learning stuff. A group of astronomers have just used the Gemini Observatory in Hawaii to take an image of Betelgeuse showing a possible companion star that has been hypothesized for decades, though not seen until now. Let's have a look. The universe is full of binary stars, multiple stars orbiting a common center of mass. Our sun, too, probably had a brief fling with a rogue planet-sized object billions of years ago, leaving it with a protoplanetary disk that eventually formed the planets we know today. Even the famously dim and nearby star Proxima Centauri, part of the Alpha Centauri system, has a companion, and the brightest star in the night sky, Sirius, also has a companion. So it shouldn't surprise us that Betelgeuse, which is not even the brightest star in Orion, also has a friend. However, the problem with talking about friends of famous stars is that, well, people know those stars pretty well, and for Betelgeuse, we have data going back over a century, and nobody had ever spotted a companion star before. In the past, people have searched for a companion and ruled out certain possibilities. For example, we know that the companion must be small, less massive than Jupiter, because if it were bigger, it would affect Betelgeuse's motion noticeably. And we have data about that going back to the 1800s. Also, if it were big, we would have spotted it already. The thing must be fairly close, though, because the star wobbles in a way that seems to require a companion. And the best constraints come from the analysis of light going back almost a century. In 2024, two independent groups of astronomers published papers saying that their analysis of historical data confirms that Betelgeuse has a companion. They inferred that the companion caused the star to wobble toward and away from us within a period of about 6 years. This would fit nicely with a simple model in which the companion star orbits Betelgeuse in about 6 years. The problem is, neither team could actually show the companion star itself because it would be very difficult to spot. And indeed, when the James Webb Space Telescope tried to take a look, it couldn't see anything. However, last year, a group of astronomers led by Jared Goldberg at the Flatiron Institute came up with a clever idea. To find the thing, they looked for signatures of the companion in archival images taken by the Hubble Space Telescope. And since the companion is much smaller and much less massive than Betelgeuse, they expected it to be bluer in color. And sure enough, they spotted a small, bright blue dot next to the red Betelgeuse in one of the images, though they could not confirm the detection. Then when the great dimming happened in 2019 and 2020, the team looked again and then saw nothing. Likely the companion was hiding behind Betelgeuse, obscuring its light. That made them quite confident that they had found the companion, but they couldn't tell whether it was really a companion without getting an actual image. For that, they needed an instrument called a speckle imager that can correct for the blurring of the atmosphere. And for that, they went to the Gemini Observatory in Hawaii. A speckle imager works by taking thousands of very quick pictures of a target and then combining them, which removes the effects of the atmosphere. The final image is like a composite of those 1,000 pictures. This method produces an image of the sky that is far sharper than what the unaided eye or even many telescopes can manage. With it, the team could finally get a good look at Betelgeuse and its possible companion. And what do you know? There was a blue star right where they expected it to be. Now, there are still a few open questions. First, it's only just barely detectable. And second, its brightness matches the expectation only if it's very far away from us, though this could be explained if it's surrounded by a disk of dust. Also, you don't necessarily need a companion star to explain the wobbling of Betelgeuse. There are other possibilities, but as co-author Steve Howell said in their press release, we can't think of any other physical explanation for the observations that we have for this system. I think this is a great example of the power of persistence. The data analysis that confirmed that Betelgeuse wobbles goes back almost a century. Then the idea of a companion comes up independently multiple times. And after that, It takes a couple more years until someone has a good idea how to spot the thing. And then it takes a bit more until someone builds the perfect instrument to do the job. And in the end, they get their reward. You know, I used to think that the Gemini North Telescope, which did the actual work in this case, is named after Gemini, the twins. And of course, that makes sense. But it turns out that Gemini is a native Hawaiian word meaning the stars that give light in dark times. I think that's appropriate. And speaking of appropriate, thanks for watching. See you tomorrow. My son is 10 now, which means he's too old for me to read him bedtime stories. Luckily, Brilliant has some beautiful courses for adults. Their newest course, The Elegant Universe, is a great example. It introduces you to concepts of quantum mechanics and string theory. And just the other day, my son told me that he doesn't want to hear anything about strings. But you don't have to worry. Brilliant has courses on all kinds of topics in science, computer science, and mathematics. All their courses challenge you with questions so you can check your understanding along the way. So go and check this out. Yes, you'd be helping yourself, but you'd also be helping us because the better you get at everything, the more we learn.